Everybody, welcome. Today we're doing a MDE mathematical sense making series, part 2. We're going to talk about sense making and the MCA. I'm sure you guys are all thinking about assessment. The window's coming up. It's probably top of your mind. That's even probably part of the reason you guys came here. So we definitely will connect that, but with some stuff to get us started here. I am Chris Jones. I'm part of the I'm the math lead for the Compass program. If you're not familiar with Compass, new program that got started, and we're really focused on the systems around classrooms that support learning of our teachers and our students in the classroom. Angela, you want to introduce yourself?
Sure, I'm Angela Hochstetter. I work primarily, on the Math MCA, all grades.
And I'm Mike Huberty, and I'm also a math assessment specialist working with Angela on the math MCAs and other projects as assigned.
And hello, everyone. I'm Sarah Vaynorf. I'm the math academic standards specialist in a slightly different team than the other three, but we are the math team from MDE, and we're super happy to be in this space.
All right, and so MDE has 10 commitments to equity, and we want to highlight those, and this is all 10 of them, but really we're going to focus in on 2 specifically today, and that is measure what matters, and for today what we're going to say is reasoning matters. What we're going to say standards matter. So this is all about measuring what matters and kind of holding that out and keeping the center of all of our work today. Also, we're going to talk about monitoring the implementation of standards. So sense making within those standards, keeping the standards at the center of what we're doing, sense making within assessment items. This is a really important one. How do we use assessment items to make sense and connect that with the world around us? But here we go. Let's get started thinking. I know it's the end of the day, kind of a big question right now. So in the year 2023, human knowledge is doubling almost every, how fast, how often, okay? Respond in the chat. What are your thoughts? So there's going to be a number and then kind of units here. So we've got a 3 years. I'm going to assume quick response. Somebody has thought about this question before. 6 months. I like that one. 2 years. 10 years. 15 months. 24 hours.
Jim, what? Ooh.
Yeah, we need units. 60 seconds. Tony, I like it. Okay, why don't we give them the number? So it's 12. Any other thoughts on that?
Ooh, so every 12.
We got
Ooh,
12 days. Okay. That would be pretty fast. That's a lot of information happening fast. Years, 12 years. I think that's valid. Months. Interested in what people are saying here now that we got to 12. Days, months, weeks. Okay, why don't we go ahead and chat GPT happen so it's going even faster now, probably. Yeah. So it's every 12 hours was kind of the number I came to. And this is a huge question, right? Like, what is knowledge? What do we quantify that is? But this was kind of a number that I had kept coming to and seeing. Either way, it is happening fast. And just kind of like, we're going to put that into perspective here. So in 1900, it was estimated to be like 100 years this happened. In 1945, about every 25 years. So you can see the speed with which information our society kind of deals with changes. In 23, we're right around 12 hours. And I'm sure that's getting faster as well. If we go on to the next one. So these are just some numbers to you. If you think about the world that we live in and how many things that are out here there to make sense of, YouTube, 300 hours of video are uploaded every minute. Instagram, 95 million photos uploaded daily. Twitter, 140 million tweets daily or 1 billion a week. And I'm sure this fluctuates and varies, but just kind of the size and scale of that, thinking about the complexity of our world that we are preparing students to go into in the future. So we really have to think about what's happened in the past and what that world is we want them to be prepared for to go into. Here's kind of another visual. So we're thinking about how are we preparing our students to make sense of the world that we're becoming. So if we kind of look at this, this is just to kind of give you a scale. We're down at the bottom where we talk about 1 megabyte, which is about a large novel or a tiny ant compared to if we're talking about an exabyte. So 2/3 of the annual production of information would be like the diameter of the sun. So we are really moving into this world that is so heavy on information, some good, some bad, that we need students who can make sense through it and kind of understand and be a part of that world, both as creators and consumers of information. And I wanted to make sure I called out one more thing, just to put it out there. No, the next one is ready, Angela. I want to acknowledge, like, it's a tough time right now to be in the classroom. There's a million things that you have to deal with. There's a lot going on. But I think sometimes that also makes us fall into this binary thinking of that there's two sides of an issue and you've got to pick one. You know, I've got to deal with so many things. How do I filter it down? We come to you in this space thinking that you can accomplish the things you want to accomplish and make sure that your standards and sense making work together to give your students more of a chance to solve problems and be part of that information heavy world that we were just talking about. Okay, now if you were here for part one, you kind of remember this. If you weren't, I just wanted to set the stage. We had watched a video where some students tried to solve a problem. About 75% of those students just gave a numerical answer. They didn't make sense of the question that they were talking about. And with that, we asked what classroom or teacher or school actions lead to these specific school responses, and kind of had a conversation around that. So if we go to the next one, this is one of the more common responses. So there's not enough time in the school year to focus on the hard skills, the calculations, and the soft skills, sense making. Standards and standardized tests focus on the hard skills more than soft skills. So we're here, we've got a couple of our test folks to kind of push back on the idea that it's just about calculations. We really think that assessments is about sense making, and those skills will help your students. In the first one, we also talked a lot about the BALDs, or the benchmark achievement level descriptors. And as you move from left to right on this chart, from the does not meet to the partially meets, the meets and exceeds, you have to sense make to get up into that world of meets and exceeds. If we want to move our students, we have to make them mathematicians that can make sense of information. So it requires that. Even if we get more specific in here and we look, you'll see some words are outlined in here. So it does not meet and partially meet. We're just talking about compute. So in that response, that was the hard skill they were talking about. Whereas meets or exceeds, we're talking about understands or justifies. So this is just kind of to think about how complex the world is and how are we preparing the students to engage in that, and what are our assessments, what are our standards, what are they really calling for? And often it's a mixture of skills and sense making to get them to where we want to go. So the excuse being, I would do more sense making, but the MCA. And we're just here to kind of say, no, to score in the meets or exceeds category, students must be able to make sense of a variety of situations. There's a ton of variety that can end up. You cannot prepare your student to see every problem that's possible in the bank of test questions. So you're really going to have to help them be able to make sense of whatever comes their way.
So
and here we go, Sarah, hop in.
Yeah. So thank you. So on March 6th, in 6 days, the state of Minnesota's MCA math window will open. And it's going to be really tempting, as Chris said, to like jump into that in very much answer getting ways. But if students don't enter this through the lens of sense making, we're not going to see them be proficient in the ways we're hoping they will be. So to prepare them, you don't want to like go and print out a ton of things and make a packet out of it and just say, do a bunch of problems. That's not going to solve it. They need to experience assessment through a sense-making lens. And so we're going to share 3 specific routines that you can bring to this with you and give you resources for all of them. So let's talk about how sense-making is connected to assessment. Sense-making, as a reminder, is one of the 8 mathematical practices that will be part of our future standards. And so that's why we're doing this series of webinars to start building what that will look like. And the good news is it connects to our current standards. In this session, we decided to bring a definition from NCTM of what sense making means. And we're hoping you'll use this with the people in your sphere of influence. Sense making is that process of students understanding ideas and concepts. Whoa, notice nothing in this says they get the right answer as fast as they can. Sense making creates these moments with students that are often signaled by students shouting out, aha, I get it. Oh, I see. Like they feel that in their head. You know how good that feels, that feeling? So the good news is in this space, we have a bunch of you, and this is where I'm going to have you put something in the chat. On the next slide is this a question. What are some of the ways we create a culture of sense making that leads to our students saying these things? Let's put as many ideas as we can get out of our brain in the chat. If you want to unmute and say something, but what are some of the things that we probably already are doing or that we could do for students to have that, aha, I get it. Oh, I see. Like what leads to that? Not how can I mimic what the teacher's doing that we talked about trying to dismantle in our last session. Awesome. Thank you, Krista. I love that. Katie, can you unmute and just say a bit more about inquiry?
Sure. I think inquiry, we need to give some tasks that where we're not just doing I do, we do, you do. We need to let them kind of discover and explore on their own. So letting them tell us the answer before we say it to them.
Thank you. Mike and Louise, I love that you said something similar. And I think when we center students' thinking, that leads to sense making as well. So hopefully that'll play out in what we're doing. Oh, I love that you're bringing up journals as well. So let's take a look at this through this problem. Again, we're going to bring you 3 routines that you could not use. Like, let's not use 40 test questions. Let's use one and do it well. So what's 3 ways we can take this one problem and build sense making in our students? And so the 3 routines, we have these little icons to go along with them. We're not even at the end of this recommending you use all 3. We're saying pick your favorite and do it multiple times in your classroom with just one problem at a time. Stop doing lots of problems that students just confirm I'm good or I'm not good with things. So let's start with routine number 1. Routine number 1 and all 3 routines are built to go after how Annie Federer through NCTM in the Math Forum said, here's how you make sense happen in the classroom. It's actually pretty easy. There's 4 things and then a bonus one that she often talks about as well. And we've linked to in that set of links that we keep sharing with you, we've linked to some of her articles and videos where she talks about these things. So number 1, she says, take those assessment items and get rid of the question. Woo! How do you build sense making if the question's there? Well, questions just make you get afraid. I don't want to do this because I might get it wrong. Number 2, she says, get rid of the question and the numbers. Well, how are you supposed to do math if there's no numbers? Number 3, she says, give the students all the answers. And you might be thinking on the MCAs, I'm not allowed to give all the answers. No, but you can create the skills that will help them think about this. And we'll show you what we mean about this. Number 4, you ask about ideas and not the answers. And another bonus thing that's going to really help with all of this is building in estimation skills in your students. You cannot do enough estimation. So what are 3 routines that go after these 5 ideas? I'm going to talk about the first one, and then my peers are going to talk about the 2 others. So routine number 1, I like to call this guess the question. Hey, students, can you guess the question? Can you predict what we're going to do today? People love to guess. They love to make predictions, but predictions are based on evidence. So let's see how Annie's sense-making ideas play out with it. I'm going to play around with these 3. Remember that one question we're going to look at a lot? Let's look at these 3 things with that one idea. I'm not going to talk about all 5, these 3. So here's the assessment item. Annie Federer would say, number 1, remove the question. So boom, the question's gone. Number 2, she says, also get rid of the numbers. So let's get rid of all the numbers. And she also says, it's her 4th one, but it's my 3rd one, ask them about ideas and not the answers. So let's get rid of all the answers. So now I want you to look at what's left. If we're going to do some sense making with students, let's start with what you see. Take away some of the visual noise And start with this to start to build sense making in your students. If students went into assessments with this lens, they're going to be much better at looking for solutions that make sense to them. So let's look at how this might play out. I'm going to ask you, I'm going to model this 3-minute routine, and I'm going to ask everybody in this space to act as a student. I want you to unmute and answer my questions. I'm going to be a teacher. You're going to be the students for just 3 minutes. Or in the chat, everybody, not some of you, everybody is going to put some ideas in the chat. You ready to do this routine with me? Don't click yet, Angela, but at the end of this routine, I'm going to ask you, what did I do as the teacher to create this routine? What did I say? What did I do? And what did I do last week before I even did this routine with you? What are all the teacher moves is what I'm going to ask you at the end. You guys ready to be students? Here we go. I'm going to be Miss Van for 3 minutes. Hey class, I'm super excited that you're here in 6th grade. We've been learning a lot of math. I want to know what you notice. I want to know at least 4 things from everyone. So either unmute or in the chat as quickly as you can. Tell me some things that you notice. They can be really simple. Oh, thank you, Pam. 3 cubes. What else, you guys? I'm going to write down 3 cubes. Pretend I'm writing that down. Different size boxes, different colors. They're piled from the smallest to the largest. I love these ideas. What else? They're stacked. What else? The cubes like that, they are 1 times larger maybe. That's a good wondering. It looks like they're steps. They're 3-dimensional shapes. Yeah, we've been doing, think about the mathematics we've been doing with 3-dimensional shapes. Let's kind of think what that might be. I'm going to tell you right now, you guys are right. These are 3 boxes that are stacked on top of each other. What do you think? And you'll notice I recorded all those things that you guys were saying. What do you think the question might be that we're going to answer? Any ideas? Throw them in the chat. Anyone want to guess in 6th grade what they're going to ask us about this? We've been learning a lot of really cool math this year. What do you think is going to be the question we're going to have to answer related to this picture? Oh, what's the total volume? What's the total volume of the box? I wonder how many yellows will fit into the blue cube. What's the surface area? We've done some surface area this year. We've done volume this year, and we've thought about proportional reasoning and how many fit into something else. I'm going to give you a little more evidence. I'm going to show you what the answer choices are. You still don't know what the question is. Do the answer choices give you any evidence to predict the question? I see some nodding heads. Someone unmute and tell me what somebody feel kind of confident they think they know what the question is going to be based on the evidence. Let's make a prediction. We're all pretty smart. Ooh, I love the stuff I'm seeing in there. Those units are super helpful. Anybody want to say some more about that? I agree. I love the stuff that's in the chat. Even if it wasn't your idea. Anyone want to unmute? I can wait you out, or I can call one of you out. Somebody tell me what you think the question might be.
Because it has inches cubed, volume is a 3-dimensional measure.
Oh,
How
thank
much
you.
space something takes up.
So you're noticing that the label that labels each of the answer choices is inches cubed, and that's your evidence that's probably about volume. Well, I'm going to give you some of the information that they gave us about this. Notice I haven't given you the numbers yet. So they're going to give you the side links, because we're going to need that information to find volume. And then if you click one more time, you'll see you guys were absolutely correct. Now, don't be scared. I know those are the F word. But let's take a look at what the question is. The question is exactly what you said. What's the total volume of those 3 stacked things? So when you think about it, how could we do that? All right, I'm going to stop being Miss Van. You guys can be teachers again. Remember I said I was going to ask you, what are the teacher moves? This is the routine. Guess the question. What are the things that you saw me do in this routine? Put anything you saw me do in the chat or unmute and tell me some of the things you saw me do. By the way, notice and wonder, are there, because they're safe. You can't get those questions wrong. Yeah, I was strategic in revealing parts of that. Krista and others have been using this phrase, low floor, high ceiling. If you don't know what that is, it's a great thing to Google, because this is part of how we construct routines with students that allow them to build sense making. prediction and explaining why, and what was the evidence that led to that. Did you know a lot of times students can look at the answer choices and they probably can figure out what's even going on in the problem. And often they don't even look for evidence that would help them do a better job. And they can prevent mistakes that are happening. So if you click ahead, I made a list, and you can steal the slide because we've already uploaded in that folder that we keep sharing. I made a list of all the things I did to create this routine in my class. And it's better to just pick one problem and spend 10 minutes on it with your students and do it well than to do this lots of time without having discourse and having to justify and build all those things in. It's a routine to build that sense making into your students. So let me show you a couple other quick examples, and then I'm going to turn it over to my colleagues. Do you see all the visual noise in this problem? Students will often go to the test and then just shut down because there's so much stuff going on, and they tend to just go to the answer choices, and they have a 1 out of 4 chance of getting it right. And they just go to their calculator and say, which one can I find on my calculator quick? And they pick that. They don't even bring sense making into the equation. So how could I take 2 questions at the same time and do this? I'll show you. Here's what it would look like in my class. Notice I took away the question, I took away the numbers, and I'm going to ask you to make some connections. Hey guys, what's the same and what's different? You don't have to answer, but imagine what students might say. You might look at the one on the right, the green one, and be like, I bet that's going to be perimeter. And you might look at the one that's all filled in and think, I bet we're going to have to estimate area. Well, if I give you more information, check this out. Do you think the one on the left is perimeter and the one on the right is area? Ooh, so it's a little counterintuitive what they might be. And so maybe I don't give these pictures. Maybe instead I give you the answer choices. So if you go to the next screen, you'll see a different version that I could have done. I could have just skipped the pictures altogether and just given the answer choices to 2 problems and say to my students, hey, what's the same and what's the difference here? They're measuring something is the same. There's 4 choices, that's the same. They're different because one's in miles and one's in inches, but they could go through. So what do you think would be different? Let's predict what the questions would be. They slightly look different. What might be the questions? And you're helping them get evidence rather than telling them. You're building sense making in them. So if you want some examples, I got all these from the Minnesota question tool. And what I often do, if you click ahead, is I just go find something like this. There's a question there. This is actually not multiple choice. This is the multiple select one. And I remove the question and I ask about ideas. Hey, what are some of the questions we could ask about these tables? What have we done this year around information that's in tables? What do you think the question would have been? And all of a sudden you're reviewing lots of different things at the same time with one problem and having them make sense out of what information might be there. So if I was going to have students do independent practice with this routine, this is our first routine. Here's what we've put together for you. I've put together a Word doc that you can edit. And I've showed you the example that I often do first with my students. One, a problem done well. Part 1 is give them a bit of the information and ask some questions about it. Part 2 is to give them a little more information and ask some more questions about it. And then part 3 is the reveal. And after the reveal, guess what? There's still more questions. And look what's on this document, a link to the Minnesota question tool, because there's hundreds of these items. If I was going to give something to do in class for practice, I would give something that looks like this. Notice it's not a 2-page thing. It's 1 page with just 4 questions on it. Guess the question. The other one is an answer key. Stop doing 20 problems. Do a few things well. And I've just made it editable because I can't do it for every grade. And honestly, you'll do a better job if you make it yourself. So let's look at the second routine.
All right. So I'm going to start with sense making in the wild. And so this is actually, I was helping my daughter just the other day and I saw this just come to life. So she let me take pictures of it and I promised her she'd be on the YouTube. So it's okay. We have an agreement. So we were looking at this, and when you have a mom that does math, as you guys that have children probably know, they're like, Mom, is it right? Like they're super addicted. Is this right? Can you check it? Is it right? And so I was like, hun, let's wonder, like, does that make sense? I was looking at B specifically in case you were wondering where my eyes were drawn to. And I was like, all right, so this is when I was like, we really need to talk about estimation. I totally agree. And so thinking about Annie Fetter stuff, we're going to really focus in on estimation routines, but bringing in the other parts and, 1,530 eggs. Not sure that's realistic, but we'll find out because we're going to estimate. All right, so this one routine is with estimation, what number is too high, what number is too low. And what's great is that you can bring students in no matter where they're at, because sometimes they really feel like this. I don't know what the answer is, but we can help them see what's close because they can find what's close because they know more than nothing about whatever it is you're talking about. They know more than they think they know. So let's make sure we get them there and help them get braver. A lot of them are brave to just engage with us. So let's help them get braver. And one way to do that is with estimation. So thinking about what's too low, too high, and in that just right range. Now, we're going to practice this, but we don't want to say too low, too high, because we know how people are. They'll be like 0, that's too low. 1,000,000, that's too high. So let's help them get braver. So let's ask the question like, what is a close number that's too low, but not the answer? Because we're not going to actually calculate this right now. Let's just think about it. So in the chat, let's think of a number. So I'd like everybody to throw in the chat what your too low answer is, your brave too low answer. So it's close to the right answer, but definitely too low. I'm seeing 480, 500, seen a lot of 480s, 400.
I like that Pam gave some evidence of her
Hey
choice.
now.
Go Pam.
All right. How about too high? Again, not 1,000,000. We're going to be brave. And what is close, but definitely on the high end? 600.
Someone
couple of
unmute and
600s.
say why you said 600. I see a lot of them.
Yeah.
Someone unmute. Tell us why you
I
said
just wanted to be first.
But how'd you get 600?
I did 50 times 12, just like Pam said.
Awesome.
Awesome. Thank you. All right. Some students might say a little different, right? Because we're all estimating a little differently, get into it a little different ways. A student might have said 450 and 750, depending on where they were at. All right, now let's think about just, about right. That's probably not the right answer, but we're getting real close. What's your about right answer? What would you guys say? Go ahead and drop it in the chat. It's about right. Again, without pulling either out your calculator or actually, doing all your little calculations. Don't find out what the answer is and then guess something. That would be not thinking, actually, which sounds funny to say, right? Ooh, 500, 550, 540. I'm seeing 520. Okay, so we're in the 500 to 550 range for about the right answer. Cool. We're going to keep going. I got 500, or I mean, a student did because I didn't do this as student work. All right, so this might show up as a multiple choice answer. So if you've gone through and thought about what's my low, what's my high, right away, when you look at your too low, too high, what can we do? Just thinking about this. I haven't even figured out what the exact answer is, but what do we know so far? What do we know so far? Can you eliminate anything? All right, I'm seeing no A, no D. So yeah, those are too low. So they're out right away. And I've already taken my chances of guessing from, 25% to a 50-50. But we've practiced this skill. So now we're going to do it. We're going to execute. The kids will show their evidence, pick their answer, and they'll be like C. And not just because they think C is the right answer because somebody told them that might happen. That just happens to be. Don't take that home. Okay. It's not a thing. All right. So let's look at our item that we've been going through. And I use the word item sometimes, that just means question. It's just test talk. All right, so let's think about this one. Our question again is total volume, and we're going to look at too low. And I'm like, okay, I want to estimate too low, but we do have a lot going on. And I'm like, I'm just, just the bottom box is enough to be too low, right? Because, it's got to be bigger than that. I'm like, oh, they dropped the F-bomb. There's fractions. So not doing that. I'm just doing 10. And you know why I can do 10? Because I know that the difference between that 9 and 7/16, if that's even a real number, it is. Oh, I don't know. But that's how kids feel, right? And 10 is not enough to compensate for the yellow and the red pinkish box. So I'm like, I'm going to use it. So I'm like, okay, I can cube 10,000. Boom. I know it's got to be bigger than 1,000, right? What can I do now? Without even, say I don't even fill it out, the rest of it. What can we do? And somebody want to come off of mute? And all you've done is part of the routine. Yeah, I'm seeing A and B are out. I would agree. You just doing part of the routine and you're like, oh, I have used knowledge that I have about volume of cubes to help me understand this. So even if I am not at a place where I'm going to work with fractions really well, I can still use what I know, which is more than nothing, to help me understand this and make sense. All right. So now let's do too high, right? So we'll do too high and I'm like, all right, 4 3/8. Yep, still not doing it. Still not my friend. I'm gonna make that a 5. I can cube 5 even without my calculator. Boom, 125. But I know that it's not big enough to compensate for the pink box. I'm like, all right, 7. Yeah, I'm probably not going to cube 7, to be fully honest. Not if I'm doing an estimation routine. So you know what I'm going to do? I'm going to put those together because I know that is going to be bigger. And I'm going for too high. And if I do that, let's just do 10 cubed again because I've already done it. And so what's too high? 2,000. What, with that information, what can we do now? Can you answer the question?
Let's get rid of D.
Thank you, Sarah. Yeah, let's get rid of D. And so in like an assessment situation, you have shown that you understand what's happening, how this works. You have an answer. Again, in the classroom, if you are not doing multiple choice, at this point, you now have a range. You know, whatever you type in your calculator needs to be between, right, 1,000 and 2,000. So if you know, because nobody ever fat fingers the calculator. That doesn't happen. You know, if you get something that's not in that range, you're like, let me go back and check my work, right? It's another fail-safe to help students. So again, this routine is about what's too high, what's too low. So let's come back to my daughter. So we're sitting there at the table and she's like, yeah, 1,530 eggs is probably not real. And I'm like, you're probably right. So let's think about this. So I asked her, I was like, so what would be too low? Like, what do you know is definitely too low? She's like, oh, well, if I did 100 for all of them, I get 500. And that clearly is not right. That's clearly too low. I was like, okay. I was like, well, what do you know would be too high? She's like, 200. I was like, well, when you do 200, what do we get? 1,000. So that definitely eliminated the 1,530 eggs. And then I asked her about, what's about right. And I was, I'm like, she's gonna give me 600, something really cool. She's like, it's gonna be closer to 500 than 1,000. I was like, I'm not even gonna fight with you. I'll take it. Because even saying that, like, is it gonna be closer to 500 or 1,000? That takes, she had to really think about where those bars are at, proportional relationships, things like that for a 4th grader who is really annoyed that her mom always asks her math questions all the time. And so she went through, she got 630, which is still an obscene number of eggs, but the answer that this math book was looking for. So it was really fun to see and go through and walk through these steps and just help her turn on her brain, if that makes sense, instead of just like do. That was nice. Now we were showing, she's in 4th grade. We showed 6th grade. I was a high school teacher. And so I don't know if we got any high school teachers in the house. You can do this with high school. And I'm going to show you, I'm not going to go into this one right now, but here's some prompting. You can let your mind run wild with it. But in the folder, you're going to see an example. And I chose all high school examples specifically. And I went through, and one of the things with high school, well, and with anything really, like this document is editable. So if too low, too high doesn't kind of fit your context, change the words. Like, what do you know? Like, even if it's what shouldn't it be? Like one of the, like the one we were just looking at, vertex and whatnot, like what do you know it's not for sure and what can it be? And having specific answers isn't necessary. So here, just kind of what's a range, or over here, I was like positive slope. If it's positive, it's too high. I didn't even put a number, just thinking about it. Sometimes it doesn't make sense to do it too low.
So you can read this later because we know the font is small, but we want to make sure we have time to get to our third one.
Which is me. So we can't get distracted. Focus.
Good
Routine
job.
number 3, we're wanting to use sense making to make visual evidence, the visual evidence, not just visual, but to make the evidence visual for the solutions and also distractors. And so going back to Annie Fetter's, this routine is going to be giving the students the answer and asking them about their ideas about how those answers came up, and not just the correct answers, but also the incorrect answers. So you may have had a student maybe once say, why do I need to show my work? And if that has happened, and sometimes, they have the right answer and they're like, I don't need to show my work. Did I get it right? Oh, yeah, but they have trouble trying to explain this. So this routine kind of goes against that and saying, I already gave you the answer. How did the answer come there? What's the evidence for, that you can come up with? What's your reasoning for the not only the correct answer, but what reasoning do you think others would have done for the incorrect answer? Okay. So you may have seen this question before with cubes by chance, and we're going to give the students the answer. So we're going to be showing them the answer. Now, you've seen the answers already, but just thinking about what do you think? So this is my turn to ask you something in the chat or to come off mute. What do you think a common thing students would do incorrectly on this problem?
If they're not finding volume, what else might they do? Yeah, just multiply the 3 numbers. Love that.
Area, surface area. Add the 3 numbers. Find the area. Thank you. All right, let's look at the. So this is in the template that we're going to share with you also. So this is again out of the questions tool. So here are the. Oh, go back. Just showing you that these are those incorrect answers as well as the correct answer. So we know what it is, and we're asking then the students to fill in, well, not only, okay, how did you get the correct answer, but what do you think someone would have done to get the incorrect answer? Okay, Angela. All right, so we're asking about what is the potential examples, what evidence could there be that students would have come up with the other ones besides just guessing, right? And so the reveal. So here's some work in choice A there. Here's where they've added the 3 numbers. Somebody suggests that, but then multiplied by 3. We've got 3 boxes, right? Maybe that's what they did. Or, in the box B, instead of cubing each of the numbers and adding them, they're squaring them, right? And adding them together. Of course, C is the correct one. And then in D, it's adding the 3 numbers and then cubing them afterwards, right? And so these are all things that students certainly could have done. And in fact, students have done. And, they say, well, where did these come from? These are directly in the Minnesota Questions tool. So again, that's a resource. Not only do we have the questions there, but we have some possible rationales of what students may have done. So you can see that, although that's typed up nicely, it's just the same thing we've put into that box there. So you could use the same sort of thing with students, and we hope you will. So of these choices, of these 4, A, B, C, or D, which do you think students answered the most frequently? The correct answer is C. Which of these do you think is most frequently answered? Mike says B. Anybody else? I see a D. Jim D, Pam D, A. No, nobody thinks they're going to choose the correct answer, most likely, I see. All right, Angela, let's show them. So also in the Minnesota Questions tool, we do show you the percentage of students who have answered each of those 4 choices. And yes, it was B, 42%. And you can ask, why is B such a tempting option? Anybody want to venture? Why did you think B was the tempting one?
I think it's because students see squares in the boxes and they think of squaring or finding the area.
Thank you, Mike.
I think students get scared off that numbers in the thousands are the correct answer.
Oh. Nice. Yeah. Okay. You can go ahead there. So again, we're wanting students, of course, not to get distracted by, hey, they did the wrong thing and go off that way, right? That's why we call these distractors. It's the name of these. They're distractors. So here's another example. Again, an item that's in the questions tool. And the correct answer, this is not a multiple choice. This is what we call a multiple response. So there is actually 2 correct answers, and you need both of them to get it correct. So the highlighted ones are the 2 on the right. And so can I ask, why do you think a student would be tempted to, what would the reasoning be to choose the upper left distractor? I'm going to pause briefly if anybody wants to think, why would that upper left one be a tempt? The X goes up by 7 each time. Nice. Thank you. Okay.
Yeah, I see the 7 in the equation.
Nice. Okay. So again, this is out of the questions tool. We can ask again what we can do to try to help the students not be distracted by the distractors. Here's the high school example actually that Angela also brought up. And so here's that item sort of worked out about, here's the 4 options, and I chose to show you choice D done rather than just factoring. They have a calculator available on the MCA. Well, we could graph it, right? So they could find the correct answer that way. In fact, if you graph it, none of the other answers make any sense whatsoever. So use that resource. Again, this template and the tool will be in a Word document, and we would encourage you to use that, and you can grab stuff from Minnesota Questions tool, those released items. And we've got 200 to 300 at grades 3 for each grade 3 through 8. Sorry, not as many at high school, but we're working on getting more out there. So, Chris, I think back to you.
I'm going to just jump back in before Sarah finishes us off, just taking us back to where we started. We are preparing students for a super complex world. And ultimately, what we want them to be able to do is make sense of that world. And math is just one of the tools that we're using for that. So we're hoping these strategies will kind of just give you another way to help build that sense making into what you're doing. But I also wanted to illustrate and add one more thing. If you didn't know, things are growing at such a rate. We've actually, in November, the General Conference on Weights and Measures actually added 2 more prefixes. They're Rona and Quita, and that's for 10 to the 27th and 10 to the 30th for us to make dealing with large numbers easier. And that's probably not something that we deal with on an everyday basis, but just another thing that I went down a rabbit hole and was reading about and got us connected to, and Mike also mentioned it. But just realize the complexity of the world that we want our kids to make sense of as you're thinking about using these. Sarah?
So what we need to build in our students, if we want them ready for our things, is not, can you get a bunch of answers as quick as possible? Because frankly, my watch can do that right now. But we want to build sense making. So stop printing out all kinds of packets. Stop putting them on computer programs as your only means for assessment work, and do less. And you can do it with just a few routines, with things that are free at the MDE site, the Minnesota Question Tool. So we're going to ask you to go back and think about this, because ultimately it starts with this. This is Sarah Vanderwerf's classroom at South High. It starts with the standards. It starts with the benchmark achievement level descriptors of BALDs. They should be on everybody's classroom as a teacher, and you need to be reading that multiple times a year, because that is 95% of the work of your, 98% of the work of your students being prepared. Teach a rich curriculum to all students, not some students, not the ones you believe can do it, all students. Give them exposure to this, build sense-making tools. You don't have to do test prep. Sense-making is what's going to get you. That's the process of understanding ideas and concepts. create aha, I get it, oh, I see moments in your classroom. And we've given you 3 routines to do that with using Annie Federer's 4+1 ways of encouraging sense making. All 3 of our routines are connected to these things. You can easily listen to videos where she talks about this and read articles. And then we've given you a document to go with each of these that you can edit and do this for whatever grade you might be teaching. So thank you to everybody. And yeah, Jim, thank you. Read, hooray for Differendorfer Day by Dr. Seuss. It says it all. And so thank you. The link for everything that we shared is in the chat. There's a QR code for that. It's one document. Just as a reminder, if you click on what's highlighted in yellow, you will find the folders that have all these editable documents in them. You will also in a couple days see a recording to this webinar linked on that document. So we hope that you got something out of this. We finished a few seconds early. I don't know how we did it, but we'll stick around for a few minutes and answer any questions that you have. Again, our contact information is on that sheet for all 4 of us, and you can reach out if you have questions. So thank you, thank you, thank you.
And Sarah mentioned this is part 2 of a series. Part 3, we don't know what will be about because we're interested in what you would like. So if you have some ideas of what you would like us to present on for part 3 or part 4, let us know. Thanks for coming.